At number 1 is cloud technologies. So if you look at the growth potential, that estimated growth potential for the public cloud, particularly on the infrastructure as a service, where you create virtual instances like any virtual machines or any of the database services or any of the tools, it's going to grow at over 30%. So that should be a huge opportunities out there for infrastructure as a service and even platform as a service. Now you see this demarcation is getting reduced. Both of them are almost same. So it's going to go over 50% as far as I know. That is the cloud technologies. And the software as a service is about estimated to grow around 16%. So if you're with a technical background, maybe good programming knowledge with operating system, so target to learn on the cloud infrastructure. So maybe you take up a certification as well. So just a quick one. Cloud computing is a model of enabling convenient on-demand network access to a shared pool of configurable computing resources, network, servers, storage, application, and services. So the point to note here is on-demand access. So when you want to have it, you can provision it and you can drop it if you don't want. So actually the billing will happen only when you use it. If you don't use it, if you release it, that is it is just like hire purchase of any machine. Any missions, your storage, servers, application, hire purchase. So when you want to use it at cost, otherwise release it. So there are different essential characteristics is given over here: on-demand self-service, resource pooling, rapid elasticity, measured service as and when in use, and broad network access. So infrastructure as a service, platform as a service, software as a service. Software as a service is particularly like any of the ERP application you're going to use on the cloud, then it is software as a service. Deployment model, public cloud is what is expected to grow at a huge pace compared to the rest of them. The private cloud and community cloud and hybrid cloud. Public cloud is estimated because there are now better services, better security aspects coming in. So public cloud is going to estimated to grow at an exponential rate. So this, if you want to quickly understand about infrastructure and PaaS cloud, so this is where basically it is the mission on which mission in the sense the instances on which you can install tools, applications and all. So SaaS is almost like you use it, software as service, you just use it. Ideal example could be Oracle or Microsoft or Salesforce are all software as a service. So these are major players, though there are many of them. Yes, Amazon is definitely, as far as infra as a service, definitely Amazon is a leader because they were the first one to introduce infrastructure as a service way back in around 2012, 2013, and the rest of them followed as well, but Oracle is also quickly catching up. So as a techie, if you're a technical consultant, if you're in college or coming out, ensure to pick up skills on cloud. So that is going to be a top requirement, number one requirement in 2023, year 2023. Stay tuned. Thank you. At number 2 is full stack developments. So if you look at full stack development, earlier, about a decade back, you had a front-end developer which used mainly HTML with Java, little bit of JavaScript, and you all also had backend developer, that is mainly with Oracle, MySQL, and integration is always bit of a complexity was involved with JDBC and all, but these days it's becoming much more easy. They want same person probably get involved in the front end as well as on the back end side of it. So that's all about the web development. With Web 1.0 is what was totally a static website. It was not interacting with the database, but with Web 2.0 it needs to interact with the database for any of the data updation or bringing the data from the database. So there is always a demand for full stack developer, and it is growing exponentially, particularly with every company getting into the e-commerce kind of a business activity rather than brick and mortar. I mean, brick and mortar in the sense real estate cost is getting higher and higher. So probably instead of doing that, they wanted to get into the e-commerce space. I mean, e-commerce space in the sense they have the online store wherein just like Amazon, wherein they can order the goods, and it is just the supply chain is what they got to manage, and that is where it is getting the potential is getting higher and higher and higher. So yes, it's again a kind of a technical field. So if you have a programming skills, pick up skills on Node JavaScript or React JavaScript, apart from Angular, maybe bit of MySQL as well, but be strong in the areas of React.js or Angular or Node.js with little bit of database knowledge as well. Of course, you need to have HTML and Java as well. So that will make you through to sail through and look for a career as a full stack developer. And if you look at next year, estimated to, that is 2023, it is estimated to grow about 20%, and this is just for a small, I mean, in the Asian side of the market. But if you look at the Western world, yeah, it could be much more as well. And 2024, yes, it's going to be an explosion there, because that point of time, even now, people are moving from on-premises to cloud. So combination of cloud with full stack development, there will be an exponential growth. So get skills on cloud as well as the full stack consisting of React, JS, Angular, plus a backend knowledge on the database side, maybe the MongoDB or MySQL or Oracle. So that's the next growth segment, that is at number 2, is full stack development. Thank you. At number 3 is data science, machine learning, and artificial intelligence. Even though AI is there for pretty long time, since 80s onwards, you keep hearing about AI. The use of machine learning is much newer, as well as the data science. And if you look at the growth, we are still at the initial stages of the growth till up to maybe till next year or 2025, and then there seems to be an exponential growth in this area. So apart from the cloud and the full stack development, this seems to have a huge potential. So I mean, even though full stack, cloud, or data science, machine learning can be an independent one, there still could be always a link. There could be overlap of different tools, the technologies aspects. So it's always good to have all the good to have knowledge as far as possible in all these um, segments. So that is cloud, because if you look at it on the cloud infrastructure, you mean you could use the full stack tool, probably you might use the React tool or Python, and then use the machine learning logic to predict something. So all this could still be interlinked. That's what I wanted to convey. And we'll also see the difference. What is the difference between data science, machine learning, and AI? Let us now look at machine learning, AI, and data science. Generally, these three terms or the subject is used interchangeably, but each one has its own meaning. So it's important to understand the difference as what it is all about. So this diagram will give you the connect. So artificial intelligence, if you look at it, it's not new. It's there from 1960s, 70s and all. But those days, the processing power, the memory was less. So those days itself, people, particularly in 80s and 90s, people used to call artificial intelligence. So if you are from a computer science background, whereas machine learning and to an extent data science is recent term. So ideally, it's all subset. Machine learning is a inner subset of artificial intelligence, and data science is a kind of a subset of artificial intelligence. Machine learning can be a subset of data science itself. So this diagram gives you a big picture as what is machine learning, data science, and artificial intelligence. So machine learning is basically the innermost layer, and then comes the data science, and finally the artificial intelligence. So it is better if you take an example as such and go through it. Example, if you look at the autonomous car or self-driven car, so you can relate what is machine learning, and then the data science part of it. Let's look at how machine learning can be applied on the autonomous car or the self-driven car. The car should recognize the signs, road signs, whether it is stop sign or go slow sign, what is the at what speed it needs to travel, that it needs to recognize, and naturally it will use the cameras for that, and the camera feed is then it has to the respective program need to process it and action need to be taken, and that is where the machine learning is used. So you need to give the data set, probably it's kind of a road sign which we are aware. Suppose if it is something like a stop sign or no entry sign, different signboards, no entry sign has to be, or if it is a stop sign itself, that data should be that is called as the label data, that is fed into an appropriate algorithm. Learning is called the learning algorithm, and this is a supervised learning concept. So you need to train that, saying that to the learning algorithm, you need to say this is a stop sign or go slow sign. So it will recognize and generate a pattern, and that is called as the model. It's called the model because you use the um, maybe thousands or millions of label data which we know, and the learning algorithm then recognizes the pattern and creates a model. Once it has the model for that particular stop sign, this is a kind of a testing part, and during the production, that is when it goes on the road, when there is a, it gives, there is a stop sign or something, this will be a new data in which based on the model, it will then recognize, okay, this is related to the stop sign or this is related to the go slow. And that is how the machine learning works, and this is called the supervised learning. So the first step is the supervised learning. That is the innermost part, and that is what you need to, there are different types of machine learning, but just to understand the difference between machine learning, artificial intelligence and data science, the first step is the machine learning part. So we will, this is the first step, and once you have the learning algorithm recognizes that and knows that, and when there is a new data going to come, it generates an output, I mean based on the learning algorithm, and it proceeds to the next step. And the next step is it has to apply the brake. As soon as the car recognizes the stops, it should start applying the brake. So this is a kind of a human activity. The car should hit the brake at the right time, not too early, too late. Plus, we should mind the different road conditions, slippery road, this issues is the control theory. So all this is all about the artificial intelligence, that is the human behavior. Human behavior to a machine is artificial intelligence. Whereas machine learning is all about have an algorithm and train the machine. Initially, you need to train the machine with the sample data set, and later point of time in the actuals, based on the sample, you have the predictable output in machine learning. Whereas the artificial intelligence is a higher level. You need to have a human behavior based on the machine learning. You need to mimic a human behavior. In this case, you need to ensure that the car or the automobile stops, it should apply the brake. So that is the artificial intelligence. The data science is a much broader spectrum. So during the test, we see sometimes car doesn't react to the stop sign. But you need to analyze why it didn't stop. Maybe the stop sign is maybe not clear. So many other things. So probably tends to, by analyzing the dataset, we find out the number of fault results depending upon on the time of the day. Our car tends to miss stop sign at night. Then we see most of the training data includes only the full data light. Now we need to add a few more nighttime picks and get back to learning. So you need to, so while training using the machine learning process, add nighttime pictures as well. So this is all our data science is all about the data as such, how it is collected, how it is integrated. So all this is part of the data science. So data science is a full, it will include all this machine learning, artificial intelligence and all. So this is a wider picture as far as data science is concerned. So it's all about how data gets managed. So the innermost layer is the machine learning part, and in the machine learning part, there could be a subset of Internet of Things as well. So when you use cameras and how cameras can be interfaced with the computer, how to get the data from the camera to the computer or to the processor, you would use certain integration, data integration techniques, how the sensor data can be taken into the microprocessor. Those are the IoT part, and then comes the training algorithm part using the sample data, and then it needs to, after that it's actually the production data. Till that time it's machine learning, and then comes the artificial intelligence. You need to invoke the human behavior of the machine so that the car applies the brake. All this is all about the data science. The topmost layer is the data science, which will encompass IoT, machine learning, and artificial intelligence as well. I hope by this you have a good understanding as how they are related with each other. That is machine learning, artificial intelligence, and data science as such. Thank you. At number 4 is big data and analytics. These days, data is considered to be a kind of a gold for the any organization or any corporate, and you need to really mine it to get meaningful information from that data and use it for any of the business any business decisions. So there is different data. One is the unstructured data. Unstructured data meaning like on the social network there could be opinions which is provided, and there could be structured data within the organization which should be residing on the database itself. So you need to use all these data, particularly the unstructured data, and use it different means towards extracting that data, and then use that to derive out meaningful information. So depending upon the needs, you might use both the data, unstructured and structured data. Structured data is much more easy to extract them. Unstructured data is difficult, but that is where a lot of opportunities are available. So at 4 is big data and analytics, and this is where is the market segment looking like. It is going to there seems to be more opportunities on big data and analytics as well as we progress through the years. At number 5 is other enterprise application. This is related to enterprise resource planning, which is called as ERP. Any of the business transactions gets recorded on the enterprise resource planning, and it is not new. It's there for more than 2 decades. Only thing is, earlier it was on premises. Now it has been moved to the cloud, and that is where for this there is going to be effort, and of course there is a gradual growth of new companies which is adopting to ERP, particularly the small and medium industries, that is called as MSMEs. So particularly with the cloud, which is called as the SaaS, it's known as software as a service. So enterprise resource planning and the other one is of course the IoT, that is Internet of Things, and there is also industrial Internet of Things. So connected devices estimation is supposed to grow, and this all depends on the connectivity type, and particularly with the 5G coming up, and particularly the low power LPWA is low power wide area network, and meaning yes, on the remote places you can use it for anything like for sensing, maybe remotely like from a ship. You want to send out where you will not have the mobile signals or Wi-Fi. You need to probably send a distress signal or fishing boats. So this is the concept of low power wide area network, and all this could find newer application with IoT devices. So it is it's not going to be an exponential growth. It is going to be, it has been so far has been a steady growth from 15-16 onwards. It didn't have an exponential growth so far, Probably it could next year or something could be a little bit. See, if you look at the curve from 2015 till up to 2021, it is linear, and then there is, particularly after 5G, it could be an exponential. That is an expectation. So of course the IoT is a new one when compared to enterprise resource planning. So there could be huge, though I would not say huge, there could be a good demand compared to any other technical fields, IT based technical fields. Thank you.